now. And yes, just to hand over to James. So thank you, James, for coming to run this session for us today. James is a senior lecturer from Arden University and specialises in research methods and psychophysiology, the website tells me. So James, over to you.
Thank you. Yeah, maybe not anymore. Like all I teach now is research methods. So yeah, I almost don't feel like a psychologist sometimes. But yeah, thank you for everyone's time. If you want the materials, I've put a link in the chat box. So if you go to the OSF page and you click on the Data Simulation Summer School folder, you should be able to download them all as a zip and then open each one as we need them. So you can download the slides. There is a slight change to the packages that I put in. So my original plan wasn't to do much simulation, weirdly, for like a simulation workshop. So I thought I'd add a couple of things in. But hopefully, if you've been to a couple of the other sessions, you've used Lisa's Faux package. There's Apex in there as well. So if you just want to install those at the start, if you have file 2, you can install the ones we'll be using. And then file 3 will be the one we'll be going through. So structure of today, going to talk for 10 minutes or so, just to hopefully you'll be a bit of a captive audience, but if you need some convincing about how simulation will be useful for pre-registration, going to outline that at the start with these slides. For the bulk of the session, going to go do a guided example using R with R Markdown, going through different steps of pre-registration and the kind of key points you can use simulation to really optimize this process. So from sample size justification and paralysis that there've been some sessions on, thinking about data processing steps, statistical models, data exclusion. So hopefully this will be a little bit of respite for everyone, where it had lots of stuff on different ways you can simulate data, different ways you can apply paralysis. This is more about thinking out how you can use them as where you can use them in like your research process. So all these different things, different ways you can apply simulation to make this more informative. And then the last thing, it's so decent chunk of time for any questions as like an overall. And then if you want to work on your own pre-registration, so apply some of the stuff we've done, happy to just sit here for the rest of the slot. If anyone has any questions like, oh, how could I do this using this template? How could I approach this? Then you can ask that as well. So as a entry-level starting point, so the whole idea behind pre-registration is at the start of the research process, so typically before you've got any data, having a timestamped document for your design and analysis plan. So you're trying to tell people, this is what I planned on doing at the start of a process, to prevent these decisions being made after the fact. So having your design and analysis decisions upfront before you see the results. So what we're trying to avoid is your results kind of affecting where you take those decisions. So we're trying to keep things honest and distinguishing between the things you're exploring, which is absolutely fine, and then the things that you'd planned from the start. You want some solid confirmatory analyses. There's nothing wrong with either of these. If you have all your studies exploratory, all is confirmatory, not a problem. The problem is when you dress up exploratory analyses as if you'd planned them all along. So having those results playing into your design and analysis decisions to make it look like everything was planned all along. But then the key thing to remember, although we're trying to make a very concrete plan at the start, doesn't mean that that has to be set in stone. So there's a really nice saying called, it's like a plan, not a prison. So all it forces you to do is confront those decision-making processes. So if you have a more detailed plan at the start, you can go, right, this is what I wanted to do, but then because of reasons X and Y, I had to do it this way instead. So it's making that decision-making process very transparent from what you wanted to do to what you could actually do at the end. So we're trying to solve different types of problems with pre-registration. So well, I guess over the last decade or so, highlighting specific problems with research processes. So having these research degrees of freedom, so these decision-making aspects. So what do you use as your dependent variable? How do you process your data? How do you identify outliers? These in isolation all seem very subtle and maybe insignificant for what the results will turn out to be. But there are different studies showing how these can have a substantive effect on the results. So for all these little decision-making processes, we're trying to constrain them from the start. This is how I plan to do it. And then you've got to be honest at the end for how you actually did it. Big history in medical research, but applies to psychology as well. So at the start of a study saying, I'm going to focus on one dependent variable, one outcome. And then when you analyze the data, say you collect 5, one of them happens to be statistically significant. And then you go, right, that's what we planned on doing all along. So to try and stop that advantageously switching the outcomes to make it look like your research was more successful than it really was. The key part of pre-registration is having your hypotheses very clear at the start. So this is about distinguishing what your confirmatory analyses are trying to be, so what you're trying to address from the start, to what you was just playing around with, seeing what happens in the data. Sort of long history of people reverse engineering the hypotheses to make it look like a nice, clean story that this is what I predicted. Lo and behold, this is what I came out with. Everything is nice and shiny. So it doesn't matter if your predictions are supported or not. We're just trying to compare what you predicted at the start. Did you have evidence for or against that at the end? And couldn't find a citation to support it, but one of the key things for me is really encouraging sample size justification prior to data collection. So you have lots of studies where they will just go, right, everyone uses 20 or 50 participants per group, but is that actually appropriate? So having a really informed decision about what sample size you need at the start, and then being able to reflect on that again. And then the specific things we're going to focus on today is they're all very well and good. Pre-registration has come on leaps and bounds in the last 5-10 years or so. But then there are still some things, it's become one of those like measures that people can game. So it has this heuristic of once it's pre-registered, it's instantly a better study. But even when it's pre-registered, it can also be terrible. There are some things it doesn't constrain, it doesn't do the job we're trying, it doesn't do the job it's trying to do. So as one example, there's this blog post about ego depletion and when comparing what the study did in the end and what they planned on doing in the pre-registration. And although all pre-registration helped, so the fact that the pre-registration was there allowed these researchers to go, right, this is not a very good example. This is what you planned at the start. This is what you ended up with. And it was one of those classic outcome, I guess not outcome switching. It was more of outcome suppression where they'd pre-registered like 8 dependent variables. And then in the final article, they just reported the one that happened to be very slightly statistically significant. But the fact that pre-registration was there did help. But it's not as effective as if it's very much constraining those different aspects of decision-making. Cool recent study comparing different types of pre-registration. So on the Open Science Framework, there have been different templates. One was completely unstructured. So just what do you plan on doing with your research? People could just add in whatever information they thought was relevant. And then there's much more structured options like the one we're going to use today that has very distinct sections asking you for specific information. And when they compared random selections of either structured or unstructured attempts at pre-registration, the ones that had this structured approach had much higher transparency scores. So constraining these different aspects, which we'll come on to in a second, and that was more effective as pre-registration for the ones that weren't unstructured. So we're trying to add to this and use simulation to make these decisions very clear from the start. And really cool idea of machine readable hypothesis tests. So Lisa and Daniel Larkins had a really cool article where it's having this clear connection between like very descriptive hypotheses where it's like, oh, there will be a difference. This group will be higher than this. And you often find that it's very hard to articulate how your statistical test would match on to your hypothesis. So in the past, it would just be a very, very descriptive way. But they argued to have this almost like machine readable one where it's like, right, based on your hypothesis, the data you have, the statistical test you would apply, what would support your hypothesis, what would falsify it? And they present, I think it's like a Shiny app or I can't remember the exact process, but in order to facilitate that process, so trying to do this with the pre-registration aspect. So it's kind of one of the inspirations behind this. If you can have a very clear connection between, right, based on simulated data, this is what would support my hypotheses. You then go and apply the same statistical test process. When you have your data, it's much more informative than not having it and just describing what would it. And thank you, Lisa. So no pressure. So Lisa's added the Shiny up in the chat as well. So from the back of paper, and this is one of the things in the materials I shared. You can download this as an image from their article. They had this table of research degrees of freedom that you ideally want to constrain in pre-registration. So the things I've highlighted in red are the ones that I think are very, very advantageous to use with simulation. So from the first one, failing to conduct a well-founded paralysis. You've had a couple of sessions on how you can do that, how you can justify your sample size, and ideally simulation can facilitate that. And then a large chunk of a data analysis part. So from what you're going to do with missing data, how are you going to identify any outliers, what statistical model are you going to use, what kind of inference criteria are you going to follow. These are all things that you can either describe them in pre-registration, and some of you might have done that, but if you can actually demonstrate it, it becomes much more concrete. So the idea here is how you can optimize pre-registration using simulation to make these research degrees of freedom much more specific. And then what we're going to be using today is R Markdown within that. So if you've not come across it before, I know Lisa demonstrated it in her session. It's a way that you can take R code and embed it in the PDFs, Word files. So you have the benefit of, once you knit the PDF, creates a very user-friendly version anyone can read. So the pre-registrations you might have done or seen, where it's just a Word document, a file on the OSF that someone can just read, and that's all very, very well and good. But for example, one of the studies I pre-registered in my PhD, by the time I'd done a para-analysis at the start to when I was writing it up, I completely forgot what inputs I used in GPower when I was trying to write it up. I couldn't reproduce what I'd done at the start. It's like I knew what sample size I was aiming for, but then when I tried to do it again in GPower a couple of months later, I completely forgot the process. So the benefit of this is you have reproducible code in the background. You can go back, rerun it. You know exactly what decisions, what parameters you inputted, which will help that thought process when you're looking, say, 6, 12 months down the line. And then the other benefit is this, there's a really great paper outlining how many inconsistencies there are with the statistics people report and the actual information that goes into it. A large part of this is errors in copy and paste. So being able to use R Markdown, you can reference the R code to input the values. So you've got less chance of copy and paste errors, and then you having to explain that when it comes, say you pre-register it, you then go to reference it in your work later on. And if there's a big inconsistency, it just creates a headache. So if you have that values coded in, less chance for copy and paste errors. What we're going to use, so like every good idea, I thought I had a great idea of making a template in R Markdown myself that was ugly, but it's very functional, so it works. So like every good idea, someone had already thought of it and did it better. So Frederick Aust, if anyone's used a Papaya package, it does lots of stuff on how you can make manuscripts in R Markdown and have this process. But he also made a pre-reg R package where it has different templates from EOSF, which you can use and insert the text for when you're describing things like we're going to go through. But then you can also embed R code to have a record of all these things like power analysis, how you can apply the statistical tests, that kind of thing. So that's what we're going to use because his looks a lot nicer. And then the final thing, how we're going to go through this guided example. I really like this study where they compare anxiety and confidence around using SPSS and R. So there's like a bit of teaching research comparing like anxiety and confidence with how people can interpret the output of both these statistics packages. So what we're going to do is like, that's a cool study, but there's a couple of limitations we might want to build on. So how can we pre-register to a study to do that? So we're going to look at simulating a power analysis, applying planned statistical tests, what inference criteria you're using, identifying outliers. So we're going to work through an example to see where you can use simulation in this process. A warning, I'm not the most efficient programmer. I'm going to look very silly in comparison to someone like Lisa. So the aim here is want you to see and almost inspire you to think about where you can use simulation. And then the idea is that you can then take that and apply your own process. And hopefully much more efficiently. You can use some of the examples in the other sessions about different statistical models, so different aspects of simulating data and applying statistical tests on them. So then you can build on that yourself, either in the second session or second half of the session or in the future. So before I move on to going through this, does anyone have any questions about the things I've just covered? Stunned silence. So either very clear or very confusing. So what we're going to work on first is where you can find this package. So assuming that you've got the packages I said we're going to be using, first thing is it's always a good idea to create R packages. So to wrap your code up in what's called an R project. So that will set it as the working directory. Your file paths will be relative to there. It's much easier to find stuff rather than always going from the same very high level folder in your work. So if you have our studio open, project in the top right and new project, I've already created a folder. So if you've downloaded all the materials and saved them somewhere in your computer, if you select a new directory, that'll just be brand new. If you select existing directory, you can just apply, insert a project into one of the folders. So we click on browse, wherever you've saved those materials. So mine is in a shared folder, cloud folder, sorry. And so I've got one for the data summer school. So if I click open on that, it's recognized that as a project working directory. And if I click create project, we now have maybe some of the files open. I deleted it just to demonstrate this. I'd already had the file and project loaded. So if you do need to install the packages, just this very short R scripts, just installing all the ones you will need. Assuming you've done that, so you need to install pre-reg for the start. So if you want to create one, if you click on a new file and R Markdown, assuming that you've installed the pre-reg package, you will be able to see the templates, the different templates in here. So you've got as predicted, Brandt et al., the pre-registration challenge, quantitative research. So different ones for that. So we're going to be basing it on the Center for Open Science pre-registration challenge. So if you click OK on that, this is the blank version. So you can insert your title, short title, name, affiliation, so all your key contact details. And then it breaks it down into different chunks. So we've got a section for the title. If you've used this template on the OSF before, it should look very familiar. So it breaks it down. So we've got the study information. So this is where we describe what we're trying to do, any hypotheses. There is a couple of sections where you just need to delete as appropriate. So what type of study are we writing up? So it can either be an experiment, observational study, meta-analysis, other. So you can delete as appropriate. Anything that's currently in green, so it's surrounded by these arrows, won't be included in the final document. So this is why it all looks a lot nicer and prettier than my version. Mine was just coded out and it works, but it's not as user-friendly. Yeah, Bradley. So once you knit it, so how I normally do it, oh, and that's a good reminder, actually. One of the files I've also got is an example of when I've done this for one of my studies. So obviously you've created this working example, which we'll come on to in a moment for the purposes of this, but it's not quite as well thought out as if I was seriously doing a study and getting it up and running. So what I normally do is upload both. So say we save this and we've added some things. If you click knit, but the other thing I'd forgot to mention, if you go on the pre-reg link that I've got in the slides, it explains that to knit it, it only gives you the option to knit it as a PDF, and you need a LaTeX like builder in the background. So in Mac, I think it's called like MacTech. Can't remember what the Windows version. If you don't have that installed separately, you won't be able to knit it. So you will be able to follow along and run the code chunks, but you wouldn't be able to knit the file until you've got this LaTeX software as well. So if I click knit, and we'll just keep it as untitled. We're not going to worry about this any further. You get an R Markdown tab to say it's thinking about stuff. And then once it has completed, so it should be very quick because we've got no code in it. It should give you somewhere, wherever it's trying to open it. Bear with me a second. So it will knit it to a PDF. So I normally add both. So this is me clicking too many buttons. So this is a version that opens up within RStudio. This is the blank form. So when you add all your information, it will come up like this. So what I would normally do is add both files to the OSF project that I want to add the pre-registration on. And if you add that, if you go to register, you don't have to fill the template out. You can just register the project itself. So it will create a time-stamped version of the project as it existed when you uploaded these to have the informative part of the pre-registration of being time-stamped. And then you can give people the link to that and they would be able to just open these files up. So you could also copy and paste the entries into like the form, but then it would kind of defeat the trying to avoid copy and paste errors. Awesome. Yeah, so I like it. And I haven't seen in too many places about, there we go. So some good advice from Lisa. So at the top, we've got output. So this is in the YAML bit. If you change that to HTML_document, that will export it to like a web page. It will just open in your browser and you would be able to see it. Thank you, Lisa. So that is for when you want to find it, start it from scratch yourself. Hopefully, if you've downloaded the materials, you'll have one called file-free rodent wrangle. So I've added these different things in to have almost a complete pre-registration document. So if we've got a title, so it's about anxiety and confidence, so we're just going to focus on the anxiety bit for this example. The date is, we'll insert it as the date that when you knit it. And then if you want, we can change the name part. So I can add my own name in. If we've got a collaborator, we can add them in as well. Or we can delete it and there's just one person. So same thing for your university. And if you have lots of other co-authors, you can just copy and paste these different entries for however many are appropriate. First thing, we're going to load the packages we're going to use. So there's free. Don't really need the pre-reg after this, but if we load it, just assuming that you've not done it before, these are the 4 that we're going to be basing the rest of the session on. So if you've not used R Markdown much before, we've got the YAML at the top. So everything between the 3 dashes set some of the settings for the document. Using 1 hash creates like the first level header. 2 dashes is second level, 3 dashes, so on. So when we run these chunks, it gives you the kind of warnings for all the packages. We can just close that. It's just telling us that it's added everything. And we insert everything into these R chunks. So you can create them by clicking on this button at the top. So it's like the little C and plus, and we can insert R code in there. And it's normally a good idea to give them unique names. So they have to be unique. You can't reuse names, but have them informative. Because say if you make an error and your code doesn't work, when you try and knit it, it will tell you whereabouts in the document it had an error. So if you don't include this, it can be quite difficult to find whereabouts in the document you made the error. But since this is called packages, it would tell us in the error messages the specific chunk where it made the error. And then there's these other arguments we've added as well. So saying echo equals false means that it won't include the code in the output. It will just be completely in the background. And then message and warning is false because we don't want it to report those messages we've just seen as well. So if you don't include those, when it has all the output for the package being loaded and any warnings it has, it will include that in your document as well and look very messy. One of the other files I included in the materials is file 4. If we have any reproducibility problems, so I'm using it on a Mac. I updated everything a couple of days ago, so hopefully if you've done it relatively recent, we shouldn't have any version problems. But if you're finding something's not working, I've checked it quite a few times and it should all run. If you're having anything that could be a problem, I've exported like my session info as a text file. So you can see the version of R, the version of the packages that I've been using for mine. So you can double check to see if there's any inconsistencies which might explain any errors. This last one is setting a global setting to say, right, we don't want to include any of the code in the output. So to make sure that the final one, that the knitted version is nice and user-friendly, we could include the code if we wanted to demonstrate it, but as a general setting, so we don't have to, for every chunk, set echo equals false, you can set these global settings. Then going through, For the title, it just takes it from a YAML at the top. So it just takes this metadata and adds whatever title we defined at the top. For a description of a study, well done. Really like this study where they got some people to complete a short course, either learning about SPSS or learning about R output. I think it was only over like 5 or 10 weeks. So they were just learning the very basics. And at the start, they got them to complete some measures on anxiety towards interpreting this output and their confidence in being able to do so. And then they completed the course and then measured the same things again. So what they wanted to know was, at the start, was anxiety towards R output higher than SPSS? Would this decrease over the course? And then because they completed a course in either R or SPSS, would this sort of lack of anxiety, increase in confidence translate or transfer to the one they didn't learn? So for both time points, they completed measures about R and SPSS, but then in the course, they only learned about one or the other. So I was interested in how this can translate between them. But then there were a couple of limitations. So they didn't randomly allocate people to groups. So who knows, they could have one sort of stronger group of students in the SPSS group, slightly weaker students in the R group. We've got some confounding variables we're not necessarily controlling. And then they also were only taught to learn how to interpret the output. They never actually did anything in the software. So they never learned how to use R. They never had to learn how to use SPSS. So in our mock study, we want to try and address these problems. So randomly allocate people into one course or another, try and get rid of some confounding variables, and actually getting people to create and interpret the output. So for our hypotheses, at the start, very much just building on this study. So we think that anxiety is going to be higher for using and interpreting R in comparison to SPSS. Think that anxiety is going to decrease from the start to the end for the software that they used. And then we would expect this to decrease for the software they didn't use, so it being able to transfer. And it's going to decrease, but not as much. So for the design, this is where we had these different options, so you can delete as appropriate. It's just a classic experiment. Got no blinding, so you can explain here whether you blinded the participants to the group. Be very difficult here. It's like, no, trust me, you're using SPSS. It would be very difficult to blind people to that. No blinding in terms of analyzing the data, but if that was appropriate to your study, this is where you can explain it. And the study design kept it very consistent with theirs. We're just trying to address some of the limitations, but building on it, same design. So we've got a three-way mixed design. Participants were randomly allocated to either using R, using SPSS, and then we've got two within subject variables. So we want to measure these things at the start and the end of the course, and then we want to see their anxiety and confidence towards R and SPSS. Any randomization details, we're saying we're randomly allocating people to either SPSS or R. And then we're getting closer to actually using some of the simulation stuff. So make sure this session's consistent with the summer score. We're saying we're registering this prior to the creation of any data. You can explain if there is any existing data. So say you're halfway through collecting data, you can be very transparent about that. Remember, the whole point of pre-registration is not to lock you into anything. You just have to be transparent about it. So if you do deviate from the plan, you have to explain why. It then means you would take any of those with a pinch of salt, because it would no longer be completely consistent. But the idea is that you just have to explain your reasoning. There is a timeline of that decision making. So for collecting data, we're just going to use our standard undergraduates, randomly allocate them into a short course. At the start, being randomly allocated in one of the two groups, getting them to complete the measures. In the middle, they are learning how to use either R or SPSS, and at the end, we are measuring our measures of anxiety and confidence. So with sample size, I put that we're going to sample at least 95 people in each group. So 95 in the R group, 95 in the SPSS group. And I'm saying here that this should provide us with at least 80% power to detect the interaction between time and output. So from start to finish, how do they feel about R and SPSS? So this is our two within subjects variables. Assuming that the means follow the exact same thing. So it's not quite realistic to how you'd go about paralysis. So in Ollie's talk, if you watch that, he discussed a little bit of the idea of like your smallest effect size of interest. So the idea behind a good sample size rationale is what would you not want to miss out on? So thinking about the aspects of confidence, what would you want to be able to detect? Would it be the smallest, like the minutest difference between R and SPSS? Would you have an idea about what would be useful in terms of how effective this would be like in your teaching practice? So you would have to think about the kind of effect sizes you're inputting, difference in means. But then here, just so you can follow along, just use the means that they found in their study. So trying to recreate this, but applying it to our example. So we've got a big chunk here, and this is going to be our paralysis. So I'm going to break it down, and then there's a little activity to follow this. So I've simplified it because it's using the faux package, and it does take a little while to run. I haven't used many simulations, which we'll come on to in the end. So this is where it's applying this process here as a demonstration, but then this is where you could input what you've learned in the summer school up to yet. So when you was learning in Ollie's talk about simple ways of using base R to simulate paralysis, when it was the talk on simulating regression, paralyses for regression, that kind of thing, this is where you would input it. So I broke it down for the effects. So this was a bit of trial and error to work out which one was which. So to make it clear to you, we've got effects 1 to 6. We've got a three-way ANOVA. So we've got our three main effects, 3 two-way interactions, 1 three-way. So you can input eventually the one you're aiming for. And I've then created a function that is going to capture this so we can run it lots of times for the simulation at the end. So we are using Lisa's faux package. So hopefully you caught her talk where she's going to explain, where she explained very well the ins and outs of how the package works. But to go over it, what we're doing, we're saving an object called Road and Ringle, which is us outlining the parameters of their study. So we're saying we've got 2 within subjects independent variables. So we've got 1 of time, pre and post, 1 of output, which is R and SPSS. And then we've got 1 between subjects independent variable of R or SPSS, so which course they was randomly allocated into. We then have 8 means. So this was, again, trial and error. Once you start getting more complicated designs, you have to have a play around to see where they fit in. So in the comments, I've put which conditions and which groups these relate to. So these are taken directly. Okay, see, this is where I was talking about at the start, where I'm happy to admit I'm not the most efficient programmer in the world. It works, and you will see it does take a while to run, and Lisa's got some advice on how you can make this go faster, but it's one of those, it works. It's not the greatest thing in the world, but we've outlined our means per group, per condition. We are outlining the standard deviation, the R between of a correlation between our repeated measures. Yeah, thanks, Lisa. So yeah, Sloan works better than fast and wrong. A motto to follow. So we've got our estimate for standard deviation. We've got our estimate for R. So these were listed in the arguments of the function we're creating. So to make it easy to change these if we want to. The sample size per group. So how many people do we want in the R and SPSS group? We're outputting this as long format. So to use it in Aphex, we want it in long form where each column is one variable, each row is one observation. And then just because we're using it to create the data set, when you play around with this yourself, the plot that it outputs automatically is very helpful, but not so much when we're trying to do stuff with it, when we're just creating a data set here. So we don't want the plot highlighted. To make that a bit clearer, put the full. So F or false works, but the full word is obviously going to be more informative. So we are assigning our simulated data set to Rode and Ringel, and we are now applying it to the Aphex function. So this is a really neat way of creating or using ANOVAs. So you can explain what data you're using. So the one we've just created in the previous step in the function, you need an ID variable. So because we've got the data in long form, we need to know which conditions match up with each participant. So the fur package adds that for you. We've got our dependent variable of y, the standard one, the one it does by default, and then defining our between and within subjects variables. So we assign that to an object. And then at the end, we want to isolate. Aphex gives you lots of information. We just want the key test statistics. Because it's paralysis and we're using null hypothesis significance testing, we just want to isolate the p-value at the end. So for each effect, we want to know what the p-value was. So we save it as a data frame, and then we isolate the p-value right at the end. So the last argument in the function was the effect. So this is the list at the top. So if we entered 1, we would get the main effect of course. If we entered 2, main effect of time, so on. So this is what the function does. So if we click Command and Enter at the function, hopefully it all works. So we've now got that saved as a function. And then the next step is where we can apply this para-analysis procedure. So repeating this process over and over, seeing how many times we observe either a significant p-value, so anything less than the alpha you choose. We're going to go with the standard less than 0.05. But obviously, you can make an informed decision about this. I've only put 100 simulations for this just because it takes a while because of my inefficient code. Really, this should be a lot longer. So when you do this yourself, recommend at least having it as 10,000, so 1E4. It's going to be much more stable, but it would take a while with how it's set up now. Set a seed to make sure you should get the same answers as I do. And then we're going to, however many simulations we set, so 100 here, repeat and get a vector of our p-values. So for each iteration, get our list of p-values that we're getting from the analysis. And we are putting parameters of 1.5 for the standard deviation, 95 people, and correlation of 0.7. And we want effect number 5. So we're interested in the interaction between time and output. So if you set this to run, the one thing I tried to find out some advice on is how you could stop getting a message outputted every single time, which is super annoying. But I couldn't find a way to stop it. So in the console, you will get, like, every time Aphex runs, you will get a message saying where it's setting the contrast to. You can ignore it. It's just for your information on what it's specifying. So once this is run, we will get a vector of 100 p-values for our 5th effect. And then the last step will be seeing how many times we got a significant p-value, so anything less than 0.05, and outputting this as a percentage. So for this to run, see, I tried that, Lisa, and it still outputted it. So unless I did it wrong, yeah. So Lisa put in the comments, like, if you set one of the arguments to set some contrast. I think I used one of the arguments actually. What do you set that as like a global setting, or just using it as an argument? Okay, cool. So yeah, if you'd add that within the function, set that as a global setting, that should stop the message outputting each time. I'll try that in a second. Hopefully, if you've got a faster computer, it'll have worked by now. This worked a lot faster yesterday, but the Zoom is, I can hear the fan on my computer working overdrive. Here we go. So we get a giant list of that. So supernormal, we'll try it in a second to stop that. So we now have, yeah, thanks, Sarah. We've now got a vector of our time output. So counting up all the p-values from the simulations we've just run. And if we run the last bit, which should be a lot faster, apparently we have 86% power. So 86 out of 100 came under 0.05. Like I said, when you do it yourself, if you've got longer, you really want to use more simulations, use more efficient code so it goes faster, but that will be more stable. But for this example, 95 people in each group with these parameters, that's what it would, that's the power that you would get from it. And then the next bit, and then we've got a little bit of an activity, just so you could have a feel for using this. This is where you can use our, thanks, Lisa, I'll come back to that in a second. This is where our Markdown really comes into its own. So we've saved this time output power. So we can say, in just normal text, we're describing how we justified the sample size. So we're saying that we simulated a paralysis. And if you wanted to be really transparent, you could use echo equals true in the chunk to demonstrate how you did the paralysis. And you say, right, we used a standard deviation of 1.5, a correlation of 0.7, and then in these like little backticks, it is where it's saying the values that we found. So this is why we're trying to avoid some copy paste errors. So if you have like a backtick starting with R, and then you can reference these values that you've saved. So you can set, so for the time output power, if you highlight that and enter it into the console, that will be input in 86. So as long as you have it saved as an object, you can use that for our Markdown to reference it. And when we knit the file, it will input that as 86% power, making sure we try and avoid some of these copy and paste errors. So the little activity, so for people to work on for a couple of minutes or so, we've got two small ones so you can reuse some of these chunks. First one is, what power would we have to detect the interaction between time and course? So might get some differences in values depending what seed you've set, but think about which bits of the code you can use from above, which which arguments you would need to use. So instead of the interaction between time and output, which we'd put as effect 5, which one would we need for time and course? And then see if you can add in, we won't knit it yet because it does the simulation and it takes ages. Add in like another paragraph where you've got the backticks to save the object you've created. So there's one for that. And then what would you have if you repeated the one from the chunk, but instead of assuming a correlation of 0.3, what would you have if you assumed, instead of 0.7, 0.3, sorry. So this article was an actual good example of reporting misinformation. I can probably count on one hand how many times I've seen an article report. So unless it's looking at like regression or something, actually have a correlation matrix between repeated measures. So it's able to look at what kind of values they had between their repeated measures. So the highest was 0.7, lowest was about 0.3. So you can see how that affects what power you'd have. So you can work on that. And I guess this is another period where if anyone has any questions, more than happy to take them. And sorry, Lisa, like going back to your comment. So you said outside the function, like don't use like the affix options. Is that the same thing for the setting the contrast, or do you have to put that in the function as well?
Put both of those outside the function. I'm rewriting your simulation to make it go faster, and I'll send it soon.
Thank you. Yeah, I've had the benefit of this before. Like the first time I tried sharing something about using like an R script, someone went, "Oh, that's really nice, but like you can use half of the lines by just doing this instead." I was like, "Okay, thank you."
There's never anything to be ashamed about by having inefficient code. Like working code is good code.
Thank you. Yes, fortunately, I don't mind a bit of the self-deprecating humor. So let's have a go. Yeah, I think it's one of those things that always helps. So if people aren't seeing the chat box, Sarah put like, "Oh, girlfriend always looks at my code and says, yeah, you can do that in like a fifth of it and don't even use R." Sometimes it's just one of those you need someone else to look at it where it makes sense in your head, but whether it and someone else just like, yeah, you can cut out like half those steps. So it's always good to have someone else to look at it. So in theory. Yeah, I think it's one of those things that always has like a bad rap. Like I like them because it's like it's easy to follow. But yeah, like you hear nasty things about for loops. Yeah, thanks for that, Lisa. Yep, stop the annoying messages. See, Matt's good, Brad. So he'd put in the comments that hate opening older R files where I've used 100 lines to do something that could be 10. But the nice thing is, if you open that and you've recognized that, it's like a really nice way of showing what you've learned in the time in between. So I've done that in the past as well, where like the simulation that I said I'd included as like an example, I look at that now and yeah, that was quicker. Thanks, Lisa. Yeah, if I look back at that now, I'm like, oh, it works, but oh my God, like, why did I do that at the time? But if you're in that position, it shows that you've grown. It shows that you've learned something more and better in the meantime. So it's like a nice marker of what you've learned. how are people getting on with reusing some of this? Give people another 2 minutes, because this is the longer part of the demonstration because of the simulations taking ages. Some of the other chunks won't take quite as long, so we still should have 45 minutes or so at the end for any questions and working on stuff yourself. And I guess one thing to comment on here, where I think it's been included in some of the other talks as well, where this process can be really helpful and include something a bit more visual. You can create like power curves. So rather than me just entering 95, you can create, say, like a data frame with different values of sample size, run it in a loop to simulate it per sample size, and see what power you get at different ones. And you can visualize that quite nicely. But I avoided it here because of how long the simulations have taken. I thought it would be very boring just watching me listen to the whirring of my computer fan. Right, what I will do is input like the kind of thing I was thinking. So what I was looking for with this is reusing function. So being able to reuse this part, but instead of time and output, instead we want time and course. So I'm going to keep the options. Apart from instead of effect 5, we want, where are you? Effect 3 instead. So if we set that to, forgot to set a seed. Awesome, thanks, Sarah. So we save the 100 simulations to an object, and now, so I'm sure this will also horrify people of copy and pasting code, but to speed things up a little bit. So again, we want to count how many times it was less than 0.05, divide it by how many they were, and times it by 100. So we get, so 24. Updated more efficient code. Yeah, thanks, Lisa. Yeah, I'll add that in. I'll update the materials after. So if you want to base this on more respectable code afterwards, that's great. So yeah, so if you use the set the same seed, you get about 24% power. So it's one of those, I think in the original study, I think there's about 30 or 40 people per group. I did include the PDF of the article as well, if you wanted to read it and you couldn't get access. So I think they got a little bit lucky. And then for reusing just the complete original bit, again, apologies for the just copy and pasting it all. We have correlation of 0.3 instead. Awesome, thanks, Lisa. And yeah, 40. So same thing as Sarah got. So instead of our 86% power, whatever it was at the start, if we have a smaller correlation, it decreases power. So the higher the correlation between repeated measures, the smaller the sample size you would need, holding everything else constant. So moving on to some of the other things we can use simulation for. So some of the sections, so we're just saying a stopping rule. So this is one of those other constraints that we're trying is how many participants will you use? What is your plan to, where should you stop collecting data or things like that? We're outlining our variables. So manipulated variables, independent variables, or whatever you're comparing. We then have our measured variables. So in the article, they use 2 items for anxiety, 4 items for confidence. So we're just explaining what items we're going to use from those to be very specific. Use the mean of either 2 items or 4 items, depending on the dependent variable. So this is another place where you could use simulation or at least demonstrate it with code. So if you have, say, some pilot data that you have and you want to demonstrate how you will create your dependent variable and make that very clear, you could include that here as well. I didn't think it was necessary for like 2 or 4 items and just taking the mean, but if you've got something more complicated, you can obviously outline the data processing steps for you to get to any indices. So how you're taking your measurements from your participants and get them into a form you can analyze. So next up is the analysis plan. So statistical models. This is rerunning the thing we just did, but once. So exact same settings, but we're just saving the function or saving the ANOVA on its own. And then we are just isolating some of the key information. So it's going to take a lot less time as we are not simulating. We're just using one instance of it. And there are 2 key things we can demonstrate. So the idea behind a statistical model is you can obviously describe like, oh, this is my hypothesis, this is what I want to test, but you can actually demonstrate how you will analyze the data. And then the idea is, but with a really effective pre-registration, you can then just substitute with this with the real data. So there is a very clear connection between what you had planned on doing and what you put in your pre-registration to what you actually did at the end. And going back to the, it's a plan, not a prison, you can change your mind. If you find that there is, say, something wrong with the assumptions, you have to correct for something, apply a different model, take something into consideration, you have that sort of paper trail of, this is what I planned, because of reasons X and Y, I had to use this instead. And it's much more transparent than if you go, right, let's just see what works. So in the final document, there is a cool package within Frederick House, Papaya package, where it will give you like an APA style table. So if you put like a data frame into it, it will format it in APA style. But I didn't want to add in like another package for you to install, just for the purpose of this. So we can just demonstrate, right, based on this simulated data, this is what the ANOVA would look like. So we just get a table of all the values. We can see what's significant, what's not significant, like the effect sizes, that kind of thing. And we can also demonstrate this visually. One of the really cool things, if you've never used Aphex, is once you save an Aphex object, it has its own function to plot that as well. So what you have to do is insert the object, so the thing we saved at the top, say what we want on the x-axis, say what we want as like separate lines, and then if you have a third independent variable like we do here, you can have like separate panels as well. And then hopefully you've used either from your experiences VAR before or some of the other workshops, it uses ggplot. So once you have that initial object, you can customize it with different functions from ggplot. So to make it look, either change some of the settings, make it look a little bit more attractive. So we save that here under our plot for Road and Ringle, and we can include it here as well. When it thinks about it. And it gives you this really cool plot. If you've never used it, like I always use it if I'm ever using like just like a basic ANOVA, it's a really effective way of visualizing data. So you can use this in the knitted document to sort of demonstrate, like, this is what I think the data will come out with. Remember, the idea behind pre-registration is we're saying this is the plan. This is based on simulated data. When I get the real one, I will essentially follow the same process, but it's with the actual data I have. So as a next activity, one of the things you can also do, say you have more complicated design and you're interested in specific effects, it will give you a warning to say that, like, once you drop certain effects, like, by the way, you're ignoring this. But say if you just wanted to focus on time and output as your two variables. So if we just wanted that two-way interaction, that single interaction, sorry, between time and output, how could you use the code from here to ignore what course people did? So for the effects we powered before, imagine we just wanted to focus on that aspect of it. How could you delete one of the arguments to get a slightly different graph from it? Yeah, so Sarah put in the comments like, yeah, you plan to do a t-test, but you found there's some problems with the assumption, so you use a like Wilcoxon, Mann-Whitney, whichever design you're applying it to. And although that was in the pre-registration, you have to do what is appropriate for your case. But what it does force you to do is account for that decision. So in an ideal world, this is what I wanted to do, but because of this reason, I had to use it instead. Sorry, I'm hoping you can't hear that chainsaw in the background. So with this one, the idea was that you can just delete the trace argument. So if we just copy and paste this bit, if we, not the trace bit, sorry, the panel, my bad. If we delete that, it will tell us about it. It will say it's probably a bad idea. So we get the error code in the bottom. But instead of getting two separate panels as well, we just have that 2x2 element. So we can see the output that people completed, the time, so from start to finish. So we can see the pretty clear pattern of what the authors expected. Of anxiety was like higher at the start than at the end, and R kind of stays slightly higher throughout. If you have any planned transformation, so if you know, for example, that your variable is never going to be, say, like parametric, and you have to apply a transformation, you have that planned from the start, you can explain that. For inference criteria, so here we're using p-values. Obviously, these things apply to, if you say you use Bayesian stats instead, you can explain what you're going to use. So one of the cool functions, if you've not used it in the past, you can adjust for multiple comparisons. There is a function for that. So part of the output, we isolated the p-values from the table. So when we had the table to demonstrate the type of analysis, we can save, say, like just the p-values. So it ranged from pretty small, so just giving you zeros just because rounded 2 decimals, all the way to a p-value of 0.65. And what you can do is, if you save that as a vector, so we've got 6 p-values, 7, sorry, you can use this function called p.adjust, and there are different methods you can use. So if you have that saved vector of p-values and you run that instead, say if we was worried about multiplicity, so everyone knows about if you perform lots of tests, you probably want to correct for the p-values across them. But what can be underappreciated is if, say, you have like massive ANOVAs. So here we've got a freeway ANOVA, you've got 7 effects. You can have a problem of multiple comparisons within that. So what you can do is correct for multiple comparisons within it. So if you apply, say, like the Holm correction, some of the p-values have changed. Most of them doesn't actually affect the decision making here. So we didn't have anything that was significant at the start, and when we apply the correction, is no longer significant. Some of them got a little bit higher, but then we had 1.6, but it's above alpha anyway. And as the last activity, then is one last thing to touch on for what you can do with simulation. What happens if, although it's usually a bad idea, what happens if you just use the classic Bonferroni correction instead? Yeah, Sarah. So yeah, Sarah put in the comments that you can use the Benjamini-Hochberg correction instead. My personal favorite's the Holm. But then if you look at the different options you have, so if you put p.adjust, you can see the different options available for doing it. So you can either do nothing, you can do BH, which is what Sarah put. What about if you put Bonferroni instead? So normally a bad idea if you've got a lot of corrections to make, but pretty simple. And then the last thing we're going to look at is how can we identify outliers, and how can we put in a plan for that. So with this, imagine so we want our p-values, and instead of method being Holm, we put Bonferroni, but with a lowercase b. Can never remember where it's got two R's or 2 N's. And instead of some of the p-values just slightly getting bigger, yeah, we've now got pretty much all of them become, well, no, it's just the ones that increased last time just become almost 1. Most of them are still pretty low, so didn't change too much between them. But normally, Holm different options are a little bit more powered. than some of the others. We're a little bit more efficient. So the last thing is how you can think about applying any data exclusion criteria. So this is one of those that lots of people can use very opportunistically. There are so many ways of identifying outliers, what you can do with it. So what you can use with pre-registration is, again, outline that at the start. So there's a couple of articles showing how, depending on the outlier criteria you use, you can get different conclusions from it. So it's important that you at least have this is what I planned at the start, this is what I eventually decided on, and then you can reflect if that affected the conclusions you're making. So to run through this, just to set the seed at the top again, simulated the same data, just to get that as a data frame. And there is one article that there's a very popular way of identifying outliers, like, oh, well, let's see what's above 3 times like the standard deviation. These authors criticize that. So what you can use instead is something called the median absolute deviation. So what you can do is check the outlier. So we're using this data frame, and we want a value for every combination of course, time, and output. We want to isolate the median. So this is where we're using some of the tidyverse packages, tidyverse functions. So to add some new variables to help us create exclusion criteria. So by using mutate, we're creating a new column. So just to get the median. We're then creating a second new column, which is our median absolute deviation. So the authors recommend plus or minus 3. And then what we're going to do is filter that. So for our dependent variable, we're going to remove anything that's higher than 3 times the median absolute deviation, anything that's lower as well. So if you do that, you will be able to see what is the difference between the data set you had at the start and the data set you have at the end. So we save that as a object called excluded. So the number of rows we had originally, the number of rows we've just removed, and it works out at 4. So we just took out 4, very few outliers by this definition. And then we could use that to say, this is what we're going to exclude from the data analysis. So having that as nice and upfront. So for this, we could be very conservative and say anyone who had incomplete measurements, so for pre and post, take them out, we lose that as a participant. If you have different ways of accounting for missing data, if you use methods that allow you to take that into consideration, if you use it in ANOVA, it assumes you have full cases, so it would take it out originally. If you use something like mixed models, like it can handle missing data, sorry. But obviously it's one thing for you to outline it here instead. And then the last couple of things in the document is your exploratory analyses. If you have any planned exploratory analyses, which I always find is quite funny. But if it's something that you're not necessarily powering for, but you just want to poke around and see what happens, you can obviously outline that. And if there's any further details. And at the end, I'd added the references I'd mentioned for the outliers, the original study. And then part of the package is it kind of has some code to nicely format that. So in theory, if you've done that, it should knit. Unless you've made an error. So if you click knit, assuming that you either knit it to PDF or replace it with the HTML output as well, it should then have a complete pre-registration that you could add to the OSF, register, and then use as that timestamp document as what you'd planned. And then when you've finished your study, you can then compare what you'd planned to what you actually do. So we'll just make sure that this all works as intended. And then that's pretty much the session for the plan stuff. So I guess while this is running, if anyone has any questions at this point, we can start that now, because it'll take a minute or so. Thanks, Sarah. So you can see in the bottom. So if you're knitting this yourself, this is where using those labels for your code chunks comes really in handy, because it gives you like percentage of where it's at. So you can see it for mine at the moment, it's currently activity 1. So once it works its way through the different ones and gives you a percentage, you can see where it breaks down. If you have, say, errors in your code, it becomes much easier to debug afterwards. So any questions at all? Always makes me nervous when people don't have questions. Excellent, thank you. So yeah, this is where it should speed up. Now it's finished with simulation parts. It should speed up a little bit. Okay, so Sarah asked, like, how did you get the hang of doing this all over time? Trial and error. So it's been one of those where it's been a bit of a learning curve. So from initially, I done a few like pre-registrations across different studies, and like the first one was, so I made a blog post about this. It was absolutely horrific. If I look back now, like sort of cringe so much I almost like turn into a circle. And at that point, it was just put it on a Word document, try and do as much as I can. Second time, it was sort of followed the structure of like the structured OSF ones, but then it was like using that was when I used GPower for the Paralysis, and then between doing that and actually finishing the study, forgot how I'd done it. First time I did it with R Markdown. That's the example I put it in. So it was just trial and error. I thought it'd be a cool idea to wrap it up in, like, you can obviously do it in the normal template, but I thought it was like the perfect mix of being able to use the things that R and R Markdown gives you, and then having that code in the background as well, because you can then refer back to it. Like the one I've got in the folder, like I still go back to now to remember what I did. So it's just that constant cycle of you do it, and it's like the best that you can do at that point. It's like, I think it was, who was it in the comments who'd put earlier? Not to call her. So Brad had put like, oh, you look back at your old code and it looks horrible. So it's always that you look back and what you thought was incredible at the time. Yeah, you now acknowledge, like, say 1-2 years later, it's much worse. So yeah, and it looks like that's pretty much everyone's experience. So yeah, it's just a learning curve, and working out different things with our Markdown. There's like obviously some quirks, but so if you've knitted it, so to kind of like cap that bit off before we move to just any other questions, if anyone wants to ask specific bits about like trying to apply it to a pre-registration we're working on, this is what you end up with. So we've got like the title, description, hypotheses, study design, sampling plan. So you can see that when we inputted like those little chunks, like it put out 100 simulations. You want to change that at some point, but then when we put like the backticks with the R and the power we saved, we get 86% power. So obviously you change your parameters, reknit it, that value will update. So that's the real benefit of of that. Yes, I have that written down somewhere. Not from me. JB efficient. Thanks for the label, Lisa. So if you search pre-reg R package and you find Frederick's GitHub page. So yeah, this is like the warning. Well, not the warning, like the heads up. So some LaTeX distributions, so MikTeX for Windows, MacTeX for Mac. So go for the MikTeX one. And to go back here, what other stuff did we input? So we've got our slightly ugly table, but works. Like I said, if you want to download the Papaya package, that's one of Frederick's other ones with some colleagues. That's also badass. Like if you want to create like a whole manuscript with this same kind of thing, but your statistical models being able to reference the values, that's like next level of this. Within that, there is a package, I think it's literally called like APA_table. And you could wrap that and it puts it out into like nice LaTeX looking stuff consistent with APA style, but this works. We've got our figure. Yeah, we put that in, but obviously forgot to turn the warnings off. So this is what, if in like the code chunk, if you don't put warning equals false, this is the kind of thing it puts out. The corrected and uncorrected p-values, any data exclusion. So we'd reference again the backticks we took out for observations if we apply this exclusion criteria for outliers. So that's something you can upload onto the OSF, register it, and then you've got it to refer back to, knowing you've got both a PDF and the code in the background as well. So I guess so thank you for everyone's time. Hope you've enjoyed this and the other sessions. So if you do want to leave, you can do. If you want to stick around, ask questions, ask about how you could do something specific for your pre-registration that you say you're potentially working on, more than happy to stick around until 3 o'clock.
Super. Thank you so much, James. I think this has actually been one of my favorite sessions because like I said to you before, I really wanted to see an example of how to actually apply some of the data simulation stuff. So to have this walkthrough it's just been brilliant. So I really appreciate that. And I also really appreciate your inefficient code, because mine is like that as well. It's terrible. And I've got from my first PhD project, I shared the terrible code on GitHub, and I've actually got comments in there along the lines of, I know this is terrible. I've spent hours trying to make it more efficient. Can't do it. So here it is. It worked. So yeah, that's good enough. So yes, thank you so much. I'm gonna stop the recording.
Yeah. I was going to ask if you was going to do